Good morning. I'm going to start again. I had a problem with a pen. So what I'm going to present today is what we call a hyperbolic function. I hope you can hear me. So what I wanted to prove was to prove that cos theta is equals to E here, which is a natural log to the power I theta plus e to the power minus I theta over 2. So now first I have to show you that what is Euler equation. E to the power I theta is basically equals to cos theta plus I sine theta. So this implies that e to the power minus I theta will also be equals to cos theta minus I sine theta. So at this point, I know you don't know what is I. So this I will be explained when I cover the chapter on complex numbers. So here I'm just taking advantage that we have just discussed the exponent. So will help us to understand this better. Well, you still remember the complex. So this basically, I'm going to explain it here. So let's see if we add these two. Let's add these two. E to the power I theta plus e to the power minus I theta. This is equals to 2 cos theta if you add this one and that one. And then these two, they cancel out. So now I want to make cos theta the subject. If I divide both sides by 2, so this means cos theta is equals to e to the power I theta plus e to the power minus I theta over 2. So to prove sine, we'll use the same concept. So I just explained this concept using cos theta. So you'll use the same thing, okay? So in principle, that's the same way of proving it, okay? So on the next page, I'm going to relate. Okay, let me just go straight there. So on the next page, basically here we have the definition of a hyperbolic function. The function obtained by replacing I theta by theta, where I is equals to the square root of minus 1, which I said I'll explain later, because here we're not going to use this too much, but I'll just explain it when we deal with complex numbers, okay? Related, so this function obtained by replacing I theta by theta, where I is equals to that, relates to the so-called hyperbolic function defined as. So here basically what I'm trying to show you is that these two are actually related. Cosh theta and cos, they're somehow related. Sinh theta is related to sine theta. This is actually explaining the next page how they are related. This is how they are related. Cosh theta is equals to cos of, in bracket we have I theta, and I sinh theta is equals to sine I theta. So this is the relationship between these two types of functions. Okay, so that's how they relate. So whenever I give you a problem and I say that solve this problem using a definition of hyperbolic function, I'm actually asking you to use these two guys on the right hand side to solve the problem. Okay, so the question will be use the hyperbolic definition. So I'm actually referring to this. We are going to use it now, don't worry. I'll show you how to use it. Okay, this is how they are related. Now they are graphs. The graph of cosh theta looks like that. Okay, I'm supposed to use two screens. I'm not going to see if somebody is looking for me. Let me check. No one is looking for me. And if you want to ask questions, you must raise your hand. I'll be checking here, but I think you should just allow me to present and then ask questions after. Okay, So the graph of cosh x looks like this. So to plot this, okay, I have a calculator somewhere. Okay, I hope you can see this calculator. So if you want to get the cosh in your calculator, you click, I think it's hyperbolic sine. So that will give you hyperbolic sine there. So let's see, Cashew. I don't know why it's hiding. Okay, so you click hyperbolic in your calculator and then sine. I don't know, here I cannot use it, but that's how you get that from the calculator. So the graph looks like that. And the graph of sinh x, okay, the graph of sinh x, I don't know. So there's someone who's needing to be admitted. Okay, so the graph of sinh x looks like this. This is how you plot the graph of sinh x. Okay, this is a standard graph, so you can get it almost everywhere. You search on the net. Someone? Okay. Now my focus basically will be on identities. So this is where I'm going to ask you questions. Let's say, for instance, here, I have somebody's making noise. Please switch off your mics. Then we'll switch it on when you ask questions, please. Okay. Now, here, remember, with a trigonometric function, these are related to trigonometric function. We have cos squared theta is equivalent, cos squared theta plus sine squared theta, this is equivalent to 1. So with the hyperbolic function, we have cosh squared theta minus sinh squared theta equals to 1. So how do you prove that? So you prove this by using the definition of a hyperbolic function. So this is what you're going to use. Okay, so how do you do that? You square, remember, by definition, cosh theta is equivalent to e theta plus e to the power minus theta over 2. So if you want cosh squared, you just square on both sides. And here you expand. If you expand, you end up with e2 theta plus e minus 2 theta plus 2 all over 4. Okay, so if you expand sinh, this is what you end up with. Now to prove that this 2 is cosh theta minus sinh theta, you'll end up with 1. So you have to add it to subtract the first one on the second one. So this is how we'll do that. We just write it as 1 over 4 e to the power 2 theta plus 1 over 4 e to the power minus 2 theta plus 1 over 2 minus 1 over 4. Now this is the first one here, basically represent cosh, and this one represents sinh. So this is e to the power minus positive 2 theta plus 1 over 4 e to the power minus 2 theta minus 1 over 2. Okay, now basically what you have here is your RHS. So you have to prove that your RHS is basically equals to 1. So you can clearly see that this guy here, using a different color, can clearly see that this guy here will cancel this one out, and this one will cancel this one out. So you are left with 1 over 2 minus half, and this is equivalent to 1. So this means if I ask you to prove this identity, you'll go through the same steps that I've just shown you. So we have just proven that this guy here is actually correct, because we have proven that the right hand side is equals to the left hand side. We started on the left hand side, we arrive at the right hand side. Okay. Okay, so you can do that to prove also other identities. The other identity that you can prove here is this one. Cosh squared theta plus sinh squared theta is equals to cosh 2 theta. Now we know that cosh theta is equivalent to e theta plus e to the power minus theta all over 2. Okay, and then cosh 2 theta will be equivalent to e 2 theta plus e to the power minus 2 theta all over 2. Okay, this is not cos, it's cosh actually. So I'm used to cos. So this will be cosh 2 theta. So you have cosh 2 theta. So we're just relating these two. Now, the reason I'm writing that, so we have just expanded cosh squared theta in the previous page. We're going to use the same thing here that we have this one here to prove on the next page. So you are going to write it in this form. Okay, you can clearly see that here you can take out half as a common factor. So we end up with 1 plus, what will remain here? Let me take it out. You have 1 over 2, 1 plus e to the power 2 theta plus e to the power minus 2 theta all over 2. And this guy here, we can clearly just explain that cos 2 theta will be equivalent to that, which is what we have here inside. So you can replace e to the power 2 theta plus e to the power minus 2 theta over 2 by cos 2 theta. So doing that, we end up with half plus half in bracket of 1 plus cos 2 theta. Then similarly, we can do the same thing with sinh squared theta. You can simplify in that fashion, take out half as a common factor, you end up with now adding these two, you can see that minus half and minus half, they cancel out. You end up with that. You end up with, so let me just use a different color and then try to show you that it's actually going to give you cos 2 theta. So you'll have 1 over 2 plus 1 over 2 cosh 2 theta plus 1 over 2 cosh 2 theta minus 1 over 2 when you add these two to when you want to prove this. So by adding these two, this guy cancel this one, then we have this guy here cancel this one, so we add these two. Let's see, half, let me see if this is correct. So we are adding, we're not subtracting, so this is plus here. So adding these two, we end up with cos 2 theta, because we have half plus half, that will give you 1, so that's cos 2 theta. So this is how you're going to prove the identities basically. Okay, so I'll erase those things later on. Let's see. Now, on the next page, they say all hyperbolic formulae can be derived using similar technique. Okay, so there's also a shorthand way of proving this, okay, of showing, remembering these identities. That's what I'm going to discuss after proving these three. So here we just want to show, try that. Remember there I was writing on top of the others there. Here, let's do it from scratch. The answer to want us to prove that hyperbolic tan x is equals to e to the power x minus that. Okay, let's check if there's something wrong here. Okay, we want to prove the first statement. Okay, so to prove the first statement here, this one, you are actually going to rewrite tan, hyperbolic tan x as sinh x over cosh x, which is equivalent, but we know by definition, sinh x is equals to e to the power minus to the power x minus e to the power minus x over 2, and this will be divided by cosh. Cosh is e to the power x plus e to the power minus x over 2. So now on the next step, we're actually going to invert this. So we have e to the power x minus e to the power minus x over 2 multiplied by 2 over e to the power x plus e to the power minus x. So you can clearly see that 2 and 2, they cancel out. So you end up with what they wanted you to prove there. So you have e to the power x minus e to the power minus x all over e to the power x plus e to the power minus x. So we have just proven the first statement. So this one we managed to get. So similarly, the second one, we actually know that, so I'll just do it here. We actually know that sec from the hyperbolic side, sec x is equals to 1 over cos x. So for this one, 1 over hyperbolic sec is actually equals to 1 over cosh x. And we know that this will be 1 over e to the power x plus e to the power minus x all over 2. So simplifying this fraction here, we end up with 2 over, so simplifying this fraction, we end up with 2 over e to the power x plus e to the power minus x. And this actually gives you what you're looking for there. So the last one, I think I'll do it on the next page, not on this page. Okay, the last one, we can, this one I've already proven that, and this one also I've done it. So let's prove this one. So to prove this one, let's see how we are going to do that. Let's start with RHS. So for RHS, we have 1 minus e to the power x minus e to the power minus x over e to the power x. We have just proven that in the previous page. Okay, and we square this. So squared, and then 1 minus, so we expand e to the power 2x. Okay, let me do it step by step. This is quadratic actually. So we have e to the power x minus e to the power minus x multiplied by e to the power x minus e to the power minus x. Similarly, we have the same thing there. E to the power x plus e to the power, one of them must be negative, e to the power minus x, e to the power x plus e to the power minus x. You do use FOIL method to expand there. So we still have 1 minus, let's see how we expand this. This is e to the power 2x. Okay, when we multiply this one and that one, this one and that one, they give you minus 1. This one and that one, they give you minus 1. So we can just write this minus 2. This one and that one, they give you plus e to the power minus 2x. So using the same thing that you got on top, this one is similar. It will be e to the power 2x plus 2 e to the power minus 2x. I'm using the one on top to write this one. Then from there, what remains is to write it in a good way. Let's see what we do here. So you have e to the power 2x plus 2, there's the plus here, plus e to the power minus 2x minus e to the power 2x minus 2 plus e to the power minus 2x all over e to the power 2x plus 2 plus e to the power minus 2x. So from here you can check the like terms and subtract. So I'm going to use a different color. So these two, they're actually like terms and they cancel out. 2 and minus 2, they add up. So this will give you 4. And this one and that one, they add, let's see, they cancel out. So it means that your answer will be equals to 4 over e to the power 2x plus 2 plus here e to the power minus 2x. So now what remains now is to prove the left-hand side to be equivalent to this. Okay, that's what remains. You have to prove that the left-hand side is equals to that. Okay, I'll try to squeeze it somewhere here and use a different color. Then going to the next page. Let's see which color can I use. Let's use green. Okay, so you remember this will be LHS. This is equivalent to, let's see, 2 over cosh x, and then you square this. Squaring this, we have 4 over cosh squared x. But what is cosh? Cosh is 4 over, I want to write it nicely. Let me check, seems like something is missing there. Okay, the second one is 1 over cosh. So let's see how we expand this. Here we're going to have, I think I'm on the right track, it's just that I stopped. So e to the power x plus e to the power minus x squared. So you expand this, this is 4 over e to the power 2x plus 2 plus e to the power minus 2x. Now you can compare if the left hand side is equal to the right hand side. They're actually equal. So we have just proven the identity. So you should be able to play around with these identities like that, okay? So we have proven that the left hand side is equal to the right hand side. Okay. So I said that there is a shorthand way of doing things. So there's a rule that's called Osborne's rule. It states that cos theta should be converted into cos theta and sin theta into sinh theta, except when this is a product of two signs, and when a sign changes must be effected. So I'm going to give you an example of how to do this. If you forgot the identities, you can actually rewrite the identities of hyperbolic function using the identities of trigonometric functions. That's basically what this rule is all about. You use it to write the hyperbolic functions, okay? Using the trigonometric function, the identities. Let's say, for instance, another identity here. Let's use the one that you are used to. This one. We have cos squared theta plus sin squared theta equals to 1. So this, according to that rule, they said cos becomes cosh. So it's going to be cosh squared theta plus, not plus. And according to the rule, they say that if we have a product of sine, then sin theta, the sign will change. We must effect the sign change. So effecting the sign change here, this will be minus sinh squared theta, and this is equivalent to 1, which is true. We just proven this there above there. So for this one will just be a sinh A minus sinh B is equals to 2 cosh A plus B over 2 sinh A plus B over 2. So this one here, this rule here is actually going to be sinh 3A is equals to 3 sinh A plus, because here we have a product, the sign must affect the change in sign. So it's going to be 4 sinh, okay, we'll write it nicely, the sinh to the power 3A. So this is how you use this rule if you want to rewrite the identities, okay? So they've given us space, so you use that space to practice, it's fine. Now let's go to solving equations. No, maybe I'm fast. We'll go back to answer your questions later. So solving equations. So I'm going to solve all these equations, don't worry. So find the values of x for which. Okay, let me try to. Who's Matsemela? Okay, I'm listening. Yes.
So can you please see the Osborne rules again?
Do it again.
Can you see the rules so that we can follow what you're doing there when you are doing those equations?
Okay, let's use this space that is provided here, né? And ignore those words don't talk. Né? Okay, we'll start here. According to this rule, sine, we replace it by sinh, okay, and cos, we replace it by cosh. And then if there's a product of sign, we effect the change in signs, okay? So here, let's do this one. This one is going to be a sinh A minus sinh B is equals to 2 cosh A plus B over 2 sinh A plus B over 2. So here is straightforward. There's nothing that you must do. You just replace sine with sinh and then cosh with cos with cosh. Okay. I hope this one is okay. Then I'm going to move to the next one. Now this one here, we have sine. So sine will be replaced by cosh, by sinh. So it's going to be sinh 3A is equals to 3 sinh A plus. The main reason I'm writing plus is because I have a product, because sine cube A is the same as sine squared A multiplied by sine to the power sine A, isn't it? So you can see that this is a product. I'm just trying to show you that. So you must effect a change in sign. So that's why I have plus 4 sinh to the power 3A. So applying that rule, okay? So that's the reason why I have a plus. Maybe that's what confused you, okay? Now for this one, cos, replace it with cosh squared theta for this one. Now minus, the main reason I have minus, sine squared theta is equivalent to sine theta multiplied by sine theta. So this is a product. So that's why we have to effect a change in sign. So it's going to be minus sinh squared theta, and this is equivalent to 1. So this means you can actually remember the identities of a hyperbolic function by using what you know from trigonometry. Okay. So I hope now it's clear. So now what is next? Let me check if there's still a hand up there. Okay, there's no hand now. Okay, now here I'm going to solve like with trigonometric equations. So this will follow the similar approach to trigonometric equations. So to solve this one, you can actually solve it from the first principle, or you can solve it directly. So if you solve it from the first principle or definition, you are going to, you can solve it by changing cosh to e to the power x plus e to the power minus x over 2 equals to 13 over 5. Okay, and then you follow steps. Or you can write it as you apply cosh inverse on both sides. Cosh inverse of cosh x is equals to cosh inverse of 13 over 15. So solving this cosh, if you multiply a function and its inverse, you end up with x here. And then this one you punch on your calculator. So I have a calculator in front of me here. So it's going to be hyperbolic. You click hyperbolic on your phone, HYP. Then you choose number what? Number 5. So you substitute 13 there. 13 over 15. What do you get? It gives me math error. I don't know. Check that. I don't know why. Do you know why? So 13 over 15. Just trying it again. I don't know why it's giving me error. I'll focus on what I know. Let's focus on this one, this side first, and then see if it's giving us the same thing. Okay. So here, how do we simplify this one? We have e to the power x plus e to the power minus x is equals to 26 over 5. Is that the case? Okay. You don't correct me that is 13 over 15. Let me try it again. Hyperbolic of cosh, and we have 13 over 5. Now it's giving me something. Okay, so it's my mistake. So I'm going to solve using the first principle. Okay, now let's solve using the first principle. Now this equation, I wanted to create space, that's why I erased that one. So you have e to the power x plus 1 over e to the power x is equivalent to 26 over 5. So we have e 2x plus 1 is equivalent to 26 over 5 e to the power x. So how do we simplify this? I just want to make it look quadratic. Let's just try to do that. Plus 5 equals to 26 e to the power x. So we have 5 e to the power 2x minus 26 e to the power x plus 5 equals to 0. Now, you can solve this problem actually directly in your phone. Now, to determine, you just write e to the power x equals to. Now in your phone, you go to, you click a mode, you choose equations, which is 5, and then the appropriate equation there will be 3, number 3. Then you substitute the coefficient 5 minus 26, and you substitute 5. It should give you answers. What are the values of x and x1 and x2? So I'll get it from you. So here it gives me 5, or e to the power x is equals to 1 over 5. I don't know if you're getting that. Okay. If it's wrong, you'll explain to me. That's what I got. Okay. Using a calculator. Now, to finish this problem, what do? You apply ln on both sides. Ln of e to the power x is equals to ln of e to the power, not e, ln of 5. Okay. Now, by the properties of natural log, ln of e to the power x is actually equals to x. So this means x is equals to ln of 5, which is approximately equals to ln of 5, which is approximately equals to 1.6. I don't know, it will depend on the number of decimals given to you. So I just stopped there. Now you have to solve the other one. You apply ln on both sides, you'll have ln of e to the power x is equals to ln of 1 over 5. So this means x is approximately equals to, not exact, this is not exact. So ln is approximately equals to ln of 1 over 5. And which gives me this number, but in the negative one, minus 1.609. So please check if you are arriving at the same values. So this is how you solve using the first principle. You can also solve using the previous one, the one that was given undefined. It was my mistake. I wrote the wrong one. I wrote 13 over 15 instead of 13 over 5. So you can use one of them. So the first one, the one that I left math is short compared to this one. But usually if I ask you, I'll indicate that use definition or use the first principle. So I'm actually referring you to use this method. Okay. So we have find two values, x equals to that and x equals to that. Okay, we can even take this value and substitute back and find out if to check, just to check. We'll take these values here, you substitute back here into the original problem, this one here, to actually see that they actually satisfy the given equation. That so that you can, if they don't satisfy, then you leave one of them. So you do that. Check. The next problem, or this one is solved. There's a question.
Yeah. You see, how did you get the value of, how did you get the value of 5?
How did I get
the value of 5?
What do you get?
No, I wanna know how did you get it?
Okay, I just calculate. I asked you to use calculator. Okay, let's do it here. Let's go here. What you need to determine. Do you see this step here? This equation.
Yes.
Okay. I want you to let e to the power x to be equals to k. Could you please do that for me? So this equation will change to 5. Remember, another thing, maybe that is before this, let me explain something. Maybe I took it simple and it's important. Okay, e to the power 2x is equivalent to e to the power x, like this, squared. Do you know that? These two are equal. E to the power 2x is equals to e to the power x in bracket squared there. Okay, I'll erase it because it's not part of this solution. Okay, so now let's use this blue pen again and explain this concept here. So here we are going to write this as 5 e to the power x. I'm trying to do it again. Squared minus 26 e to the power x plus 5 equals to 0. So this is the same as 5, and then we let, okay, I should write it down. We let k to be equals to e to the power x. So this means this will be 5k squared minus 26k plus 5 equals to 0. Now this one you can solve it using the quadratic formula. Could you please do that using quadratic formula to check? Or you can use your calculator. In your calculator, you click mode, you go to number 5. From number 5, then you choose equation number 3. And then you just substitute coefficient. The first coefficient is 5 minus 26 and then 5. And it gives me that x1 is 5 and x2 is 1 over 5. Okay, you can take the long road, the long way, and you do what? You use the quadratic formula. Step by step, you get the solutions, it's fine. Or you can use your calculator. So sometimes you have to take advantage of a calculator. In this situation, I'll allow you to use calculator directly. I hope I've answered your question.
Yes, I just wanted that part of using a calculator.
Hello?
Yeah, I just wanted that part of using a calculator.
Okay, now you managed to use it.
Yeah, thank you.
Okay, thanks. So now this one again, we are going to solve it using what we call a definition. So this is 2 e to the power. Let me see, this is some sign that there's something there. Okay, we have a guess. Okay, so we have e to the power 2x plus e to the power, I hope you can see that, because here we have 2x, it's going to be e to the power 2x minus 2x all over 2 plus 10 e to the power 2x minus e to the power minus 2x all over 2 equals to 5. So from here, it will depend on how you approach it. Some students, they can just cancel out 2 by 2 and 10 here, and then try to simplify out. Okay, let's see if e to the power 2x plus e to the power minus 5 e to the power minus 2x. Now this one, so it's 6 e to the power x, and these two are friends, so it gives me minus 4 e to the power minus 2x equivalent to 5. Now we can write this over e to the power 2x equivalent to 5. Now we read x. So this gives me what? Let's see. If we multiply here we have 6 e to the 4x plus 4, just to complete it. Okay, write it in a quadrant. This will be e to the power what? 4x, okay, minus 5 e to the power 2x minus 4 is equivalent to 0. Now this is quadratic, but now I think it will be easy to put x minus 4 equals to 0. Okay. Now from there, this basically means that we are solving for e to the power 2x. Okay. So this means you are actually solving for e to the power 2x. So let's see. Now, remember, now you know how to use a calculator. So let's use a calculator and see. Okay, we follow the same steps as the previous one. Okay. And we'll check if we are getting the same answers. I don't know. So here I'm getting 5.7 or e to the power minus to the power 2x equivalent to minus 0.7 something. So if this is the case, because I didn't take all the values, so it will be correct for me to write approximately, and even here, the fact that I didn't take all values, so you can write equal if you have taken all values. Okay. Now, this one it cannot be done. It's not possible. So we only focus on this one. Reason being that the logarithmic limb does not take negative. Okay, we discussed that in class. So the only one that we can solve is this one. So this means we have ln of e to the power 2x is equivalent to 5.7. It's approximately equals to 5.7. So 2x, okay, I didn't apply something here. It's approximately equal to ln of 5.7. So it's approximately equals to ln of 5.7. So now we can use a calculator. X is equals to ln of 5.7 over 2. Okay, which is approximately equals to, let's just use a calculator. Now to move out, you go to mode and then you press number 1. Now we have ln of 5.7 divided by 2. So my solution here, it gives me 0.87, approximately 0.87. Okay. So that's how I have solved this one actually. Okay, this one you can even test. In your calculator, it must give you undefined to show that you can't solve it. When you take a mean of minus 0.7. Okay. Okay, so this is at this point. Now I'm taking. Okay. Any questions? Okay. So let me make sure that the recording is safe. If I don't stop it, we are not going to get it. Stop.